In today's episode, we're going to cover the top 15 terms that have been used in the crypto and DeFi space to give a better understanding and clarity about what they mean. I call them human glossary because they're not going to be very technical explanation, but a very human kind of explanation to understand these 15 terms. So I've got all 15 listed over here, and we'll just go through them one by one. So we're going to start off with layer 1. And what is layer 1? Layer 1 is, if you imagine blockchain has different kind of blocks, right? So this is block 1, block 2, and block 3. So this is basically layer 1 as in a tech stack, and then on top you could have other kind of systems and processes and technological stack. So layer 1 is really just the base layer. So examples of this will be Bitcoin, Ethereum, Bitcoin, Ethereum, maybe Polkadot, Filecoin. So these are different kind of layer 1 solutions, and you could build things on top of them. The economics involved in layer 1 is very different from the economics of layer 2 and the other kind of layers. So that's layer 1. Then what's layer 2 then? As you can imagine, if layer 1 is the base layer, layer 2 is something that's being built upon it. So layer 2 is usually what we call for scalability, to solve scalability issues, and it is built on top of layer 2. It's built on top of layer 1. So if this is layer 1, then you can imagine on top it's layer 2 to deal with scalability. And that helps things to scale a bit faster, and we're going to talk about them a little bit later. Then we have Dapp. What are Dapps? Dapps are decentralized applications. So these are basically where all your other DeFi applications, NFT applications, esports, cryptocurrency, crypto games, and all these other applications that's built on top. So they can be built directly on top of layer 1, or they can be built directly on top of layer 2. These are basically applications where you could be using them. So think of layer 1 as in iOS, so your system, Android or iOS. Layer 2 will be something very specific to Android, or a bit more specific relating to iOS and Android. And your dApps will be your different kind of Facebook apps, your Twitter apps, your browser apps on your smartphone. So this is basically the core infrastructure, the core technological infrastructure when we talk about crypto and DeFi. Layer 1, Layer 2, and dApps. Okay, so now let's move directly on to DeFi. Let's talk about DeFi money Legos and compostability. DeFi is just D for decentralized, F for finance. So this carries the ethos or this philosophy that the future of finance will be decentralized. So the whole mechanism, the whole governance, the whole technological stack will be completely decentralized. And the start for DeFi is Bitcoin, where it's a peer-to-peer currency. And now we have moved on now we have developed a little bit more than just peer-to-peer. So now we have lending, we have exchange, we have derivatives. So decentralized finance has grown a lot to be more than just what P2P lending is all about. It's a lot more than just Bitcoin. So that's what DeFi is. Now let's talk about money Lego. As you can imagine, you have your different Lego bricks, and they can be stacked upon each other to be building some form of some Lego structure, which is very, very cool, right? So the whole idea of money Lego is that all these different kind of lending protocols, exchange, derivatives, all these are different protocols, okay? So they're part of dApps, the different kind of protocols. Each of them acts like one of these Lego things. So one of the cool parts is that you could build upon them, just like how you can build Legos, build upon each other, integrate the protocols together, and start building a bit of a bigger infrastructure, a bigger empire. So money Lego is basically just taking all these different protocols. So for example, we could have a P2P currency DAI. and we could get lending in, and we use the Aave platform to be borrowing and lending DAI. Then we can also integrate the exchange, let's say Uniswap, so that you could exchange Aave for DAI, DAI for Aave, or you could go to Aave and be borrowing and lending DAI. And you can even go to your derivatives platform, and let's say you can hedge. You can hedge on it, you can long, you can short, you can do leverage. There are a lot of different things. And this is basically money Lego, because you can stack different kind of protocols on top of each other. Which brings us to the next point on compostability. Now, compostability it's actually a systems design terminology or a systems design principle. It means that something can be broken down and its parts can be used in other ways. So what we do in compostability is very similar to money Lego, in which all of these different protocols, these lending or borrowing or derivatives and exchange, they can exist in their own right, but at the same time, you can use them in other ways. So, for example, you could pair them up together. For example, Cream. What Cream does is to take Comp and Aave and Uniswap. So it brings lending and exchange together as two different pieces coming together into this new platform that they are creating. So it's really compostable because these protocols are very versatile, and you could just add them together into like a Lego brick and build different kind of cool infrastructure around it. So that's the general idea of DeFi. It's moving very fast, and we're also looking at brand new ways to be playing around with them. So it's very interesting. And this has been going very well since summer 2020. There's a lot of development in this space. Now the problem, right? This is good because there are a lot of use cases and there's a lot of things going on. Now the problem is scalability. So in about summer 2020, there's so many transactions going on because of all these different DeFi and compostability and money Legos going on. A lot of transactions are being made. And what happens with that is that you have scalability issues. So if you go back to when we first started with layer 1, layer 2, and Dapp layers, what it does is that every time the Dapps, they have transactions, and then it will be approved on this base layer, layer 1, layer 2, and layer 3. That's how the whole idea of blockchain starts. If you want me to go into details of that, let me know and I will make a video of that. Basically, every transaction that is on the Dapp goes into the layer 1 so that it gets approved, it gets locked in, and it now records that transaction has happened. And that's all going in general quite good. But one of the problems is this thing called scalability issues, because there's so many transactions going on that it's very difficult to scale. For Bitcoin, it takes 10 minutes for every block to be approved. For Ethereum, it's a bit more flexible, but it can become very, very expensive. So this is where I talked about layer 2. Layer 2 comes in. So layer 2 is talking about scalability. So when we talk about scalability in blockchain, it's about increasing transactions. So we want to increase transaction throughput so that more transactions can be validated and more transactions will be added into the layer 1 main chain. So this is one of the problems that we have in layer 1 solutions. And this is where layer 2 solutions can come in. One of the main ideas is this thing called Sidechain. So imagine this is a tree, or this is a leaf. A leaf might be an easier explanation. So we have a leaf over here, and you realize that with leaves, they have little spokes coming up, right? So think of the main line of the leaf as the layer 1 chain. So this is where all your blocks will be minted, all your blocks will be approved, and what's called blockchain, right? A chain of blocks. And sidechain are these little things that comes out here. And what do? Basically, you will have your transactions, you will still do your transactions, and then it will collect all these transactions on the side and then input into one of these blocks. So instead of directly updating the blocks, every time you make a transaction, instead of directly updating the blocks, you have a bunch of updates to be done on the side, and then it at one shot bring all these transactions and update in one of these chains. So this is the whole idea of sidechains. And there are a lot of, so in sidechains, to make it less complicated, basically sidechains is a layer 2 solution. And one of them is this thing called plasma chain. And it uses sidechain technology. It has a lot of different kind of consensus. It has a lot of cryptoeconomics that goes into it, and it's very interesting and fascinating in its own right. One of the biggest problems is that it still has a lot of issues. So, for example, one of them is data availability. So, what you realize over here is that there are a lot of transactions going on the sidechain, right? That's good. One problem is that it still needs to take some time to be updated into one of these main chains. And so, number one, there will be a timing issue. There will be a latency problem because you have things being approved and then another guy here on this chain waiting for data from the sidechain so that he can make some transactions on his own. So that becomes a little bit of a problem, and it can get quite complicated and technical. So one solution that came out is called Rollups. What Rollups do, it has the same concept of aggregating everything on the sidechain and then updating to the main chain. So aggregating everything on layer 2 and bringing it to layer 1. And the good thing is that it uses the same kind of concept, and it is also good because it is less complicated than directly using plasma chain or the sidechain, because that was really complicated. So what rollups do, imagine if you have a car over here and they're going from point A to point B. The car can get one person, right, on the car. What rollups do is that instead of a car, now you have a plane, and you can have more people on it. Let's say you can have 3 people on it instead of a car having just one person. And you can still go from point A to point B. And what it does in this area is that every car has a fee. So let's say it's $3. And the plane, although it's slightly bigger, so maybe let's say it's $4, but because it has more transactions within it, so each person pays a bit less. And it's also a lot more efficient because now you can take a lot of people to go from point A to point B at once. So this is basically the idea of rollups. It aggregates a lot of transactions that's happening on the side, sidechain or off-chain, aggregates them together, put them into a plane, and then fly from point A to point B. Which brings us to 2 types of rollups there are currently out there. You've got ZK rollups and you've got optimistic rollups. I'll talk a little bit about ZK rollups. I'll link it in the video. The idea of ZK rollups is that, what is ZK? ZK is zero knowledge. So zero knowledge is not anything new. Zero knowledge is something in cryptography that was created in the late 1900s, and it's quite a big thing. So you probably heard of this thing called ZKP. So ZKP is called zero knowledge proof. And what it does with ZK rollups is that it takes the concept zero knowledge, so the cryptography thing, and then it includes rollups, which is what we talked about, the aggregation of all these little transactions going on. They put them together, and it becomes one of these scalability solutions. So now, it's the same thing. We have a plane going from point A to point B, but because they use zero knowledge in their system, so now this is by default, there's privacy involved by default, right? So you have privacy in there, and you have aggregation and allow faster scalability. So ZK rollup, amazing. It's very good. And that's something that a few companies are doing right now. One of them is Loopring, that they are using ZK rollups as one of their solutions. And a lot of people, a lot of really smart people, they all believe that ZK rollup will be the future. It will be something that's going to be very, very big in the future, and it's going to be one of these core technological stacks. And I agree with that too. One of the problems, with every solution, there's usually a problem. So there is definitely something that is apt for the future as we are growing a lot more and we're testing out the limits to all these different kind of technologies. So that's something for the future, and it definitely is going to be one of the core pieces in the future. But what about right now? Right now, today? One of the limitations in ZK Rollup is that it's still doing very fundamental DeFi things. It's still doing very much, P2P trading. So that means me giving you money, you giving me money, and then we just trade. But as I mentioned, in summer 2020, the whole DeFi space, the whole compostability, the whole money Lego thing has evolved quite a lot. So we're talking about derivatives, we're talking about exchange, we're talking about decentralized exchange, we're talking about automated market makers, we're talking about flash loans, we're talking about more complicated and sophisticated products. And yes, ZK rollups could do that in the future, but because right now, I told you about this whole cryptography zero knowledge thing, right? It is very cool and it is definitely working. It's just that it takes a little bit more processing power, it takes a little bit more time, so it's a bit slower. And because of that, it is not exactly the best to do these lending, exchange, and derivatives, right? It's still very much for P2P payment. I owe you money, you owe me money, we settle the payment. And then it becomes a very simple calculation of how much money we have left in our balances. So that's the state of ZK rollups right now, which is not a big problem. It is still being tested and modified. So what can we do today? What can be the solutions today for something a bit more complicated? And this is where we have this thing called optimistic rollup. So optimistic rollup uses the same concept for ZK rollups as ZK rollups. The whole idea of taking a plane and having all these transactions going from A to B and aggregating them together. So the problem that ZK rollup has is the complication and almost like data availability because of all these complications. And optimistic rollup resolves that. So optimistic rollup resolves that by having this punishment method. So every time all these different complicated things are being executed on the sidechain, one of these little sidechains, then it aggregates the information and then it updates to the main chain. And now now the system will just take it as that's the right set of data, that's the right set of state or right set of information of transactions that's going on until someone proves it otherwise. So maybe I'm a bad actor and I say that, okay, these are the different transactions that happen, 1, 2, 3, 4, that happens on the sidechain, and then what optimistic rollup does is that it will update the next chain, it will update the next block with this information. And to do that, I have to stake some tokens and all that kind of stuff. And now someone realizes that, that I'm a bad actor, and they can prove that, okay, these 4 transactions did not happen, these 4 transactions are fake, and then my stakes will be burnt and I will be punished. And so this is how the optimistic rollup works. So same concept of taking the plane, and now the plane is proven to be safe until someone says that, okay, I've done some checks and I realized that the plane is actually not safe. One of the wings came out and the tail doesn't fly, and then the engine is leaking. And because of that, then the pilot of the plane, the validator, will be cancelled, the cancel culture, and the pilot of the plane will be punished. So in the same way, that's how the optimistic rollup is working. And it's a lot faster, and it is a temporary solution for what we have today right now. So trying to resolve the scalability problem without having a lot of complications of data availability with sidechains, and without allowing us to use more sophisticated products than just the zero knowledge the ZK rollup does, or the ZK rollup allows for. So that's optimistic rollup. And when I first heard about ZK rollup, I was very confused at first because one of the biggest things in the layer 1 solution or layer 1 economics is this thing called ZK-SNARKS. So ZK-SNARKS, as you can imagine, ZK is zero knowledge, and SNARKS is a long word to it. I've created a video as well, I'll link it, to talk about the difference between ZK rollup and ZK-SNARKS. ZK-SNARKS is basically aggregating your information or taking only the right information without revealing your identity or without revealing too much of your information. So it's only taking the right information required. And this is very important because if we're talking about layer 1 solution, if we're talking about transparency in blockchain, or we're talking about decentralized technology where information and data is a bit more transparent, then something that you definitely want to think about is privacy. And that's what ZK-SNARKS is trying to solve, or that's what ZK-SNARKS is solving, which is the issue of privacy. And you can now send your data, send your information without revealing too much of your identity. So it uses cryptography of the zero-knowledge proof cryptography and some form of technological thing to allow for privacy in transactions. And if you imagine that allows for privacy in transactions, that's kind of what ZK Rollup also does, is that it aggregates all the information of all the transactions, but maintaining privacy of these transactions. So that's why ZK Rollup is quite kind of the future of scalability. So these are the four, in general, these are 12 different terms that talks about a bit more of the core technological stack and fundamentals involved. And now let's go to 3 other terms that I think it's quite interesting that is not many people talk about it, but I think it's very important because it's going to be it's getting very popular and some people don't understand what it is. So it's good to get started with them. The first one is quadratic funding. Quadratic funding, without going too much into details because I can probably talk a lot about it, is a new way of funding public goods. So one of these issues with crypto and decentralization and DeFi and everything is that we're creating public goods. So just like water, just like oil, just like air, these are public goods. Nobody owns them. And when we're looking at a collaborative future and a P2P system, I talked about it in one of the videos that I was comparing labor and capital and how does it affect the future of labor. I'll link it in the video, I'll link it above as well. And one of the ways for us to succeed as an ecosystem is to start producing more public goods that everyone can use. So examples of public goods will be stuff like having good UI, having educational materials, having good technological stacks that is part of these money Lego or compostability features so that we can grow the ecosystem. And how do we do that? We need funding. We need funding from the public. And so quadratic funding now becomes a new way of funding public goods. So it works in a very simple way. Quadratic is just squared, right? So what is a quadratic function? A quadratic function is something like that. So it increases by a lot, as you can see. So one idea of quadratic funding is that there is a pool of donation money waiting to be distributed to people. Okay? So how do we judge how much to distribute? So let's say I've got a charity pool and I have $100. It's a very poor charity. So I have a pool of $100 and I'm going to allocate to, let's say, 5 projects. Now, one way is to divide it equally. So 100 projects, $100, I've got 5 projects, each project receives $20. That's one way. Or the other way is to allow the community to vote, or allow the community to somehow vote for what they are enjoying, what they like. So this is where quadratic funding comes in. So we start off, we have this curve that goes up like that, and then for every individual, everyone funds some amount of money, and how do we allocate this $100 is that we want to square as you can imagine, quadratic is square, right? So we want to square the contribution and then allocate money equally. So without going into too much details, the idea is that as more people are supporting, so we have 5 projects and we have project A, B, C, D, E. So let's say most people are supporting project A, and so we want to allocate more money to project A, and we allocate it in a squared manner. So the more sophisticated explanation is that you have the sum of the square, and then you have the sum of the root square. Basically, the idea is that this quadratic funding now becomes a more efficient way to be allocating these funding to different projects that the community has voted for. So in an economics term, it becomes a very interesting binding mechanism to be rewarding and funding the right kind of projects based on what the community has voted. So once again, the idea of quadratic funding is very simple. Based on the votes or based on the donations that the project has, then the more votes or the more donations that the project receives, the more funding in an exponential term the project will receive. So that's the idea of quadratic funding. The other thing that is very new is called flash loans. That's something that has created out of the whole DeFi space, during the whole innovation that's going on. Flash loan is one of the things that appeared. So flash loan, it started with Aave, and Aave is a lending protocol. And so what Aave does, flash loan becomes a business logic, a technological logic that smart contracts can execute. So if let's say I want to flash loan, as you can imagine, flash loan means in an instant you borrow and return at the same time. So every time one of these blocks are being submitted and to be approved, then what you want to do is you have X, you want to borrow X dollars, you use X dollar in protocol Y, and then you will also have to pay back X dollars plus interest. So these three things will be executed at once during a flash loan, or when a flash loan is executed. And of course, it is executed by smart contracts. So if the smart contract calculates that by the end of this, by the end of this validation, or the end of this, you can't repay X dollars you borrow plus the percentage, then this loan will not be executed. And all you have to do is just pay for the gas. But if they realize that, okay, you can afford to pay X dollars plus the interest, then it will be approved and it will be executed. So that's the idea of flash loans, and it is still very new. People are still exploring it. So that's something definitely to watch out and look out for in the DeFi space. And lastly, front running. So front running is very interesting because front running happens in trading as well. Anyway, what front running does is that I'm running and you want to win me, so you run faster and you go in front of me. That's the idea of front running. How does it work in trade? So one of these different things, as I mentioned, in exchange is that you have your automated market makers or decentralized exchange. So these are new kind of concepts, new kind of mechanisms in the financial market, in the decentralized financial market. And that's very interesting and very cool. And so how front running works is that because in AMMs or decentralized exchanges, the prices of goods are not always fixed, and they're really dependent on the volume available, the liquidity available. And so what front running does is that if let's say I'm going to place a very big trade, someone knows that because with all transparency you can always see a trade being placed. Then what I could do is to pay a bit more gas fees, so that when you pay more gas fees, so let's say these are two things to be approved, right? 1 and 2. I'll use green. Let's say these are two things to be approved, 1 and 2. And now the probability of them being approved depends on a few things, and one of them will be your fees payable. So how does it work? If let's say block number 1 or transaction number 1 is a lot of money, and block number 2 is just a little bit of money, and they know that I can be earning a lot more, or I can be getting a lot more if I trade before you, then I will pay more fees so that my block will be ahead of yours, and I'll be approved first. And when I am approved first, then I will get a bit more money out of it, or more benefits out of the trade, or more profits out of the trade. So this is the whole idea of front running. And you could calculate this, and this becomes a risk, especially if you are an active trader, because someone can spend a bit more fees and trade ahead of you so that they can be getting the profits instead of you getting the profits. So that's one of the dangers, that's one of the risks, and there's something to think about when you are in DeFi. Front running is not exactly new, it's everywhere anyway, so it's about now that there's more information transparency, how do you deal with that? So this sums up the 15 different terms, trying to explain it in a more human form. So I call them human glossary. And I hope that explains things very well. If you have any questions, just drop them in the comments below. If you want me to go through more human glossary terms like that, just also drop them in the comments below so I can make a part 2 of it. If there's anything you don't understand or anything you want me to go a bit deeper into as well, just drop that in the comments so I can get to it. Till then, I'll see you in the next video.